Welcome. So my name is Olof Kindgren. I will talk about FuseSoC today. A little bit about myself. I am working for Camcom Research and Technology. I'm also a co-founder and director of the FuseSoC Foundation, where we organize conferences and work on open source silicon. I'm the creator of the award-winning Serve CPU, father of two not very award-winning children. I'm a viral tweeter, also RISC-V ambassador, and also creator of the award-winning FuseSoC package manager. So we're talking a lot about CPUs, but eventually you want to use the CPUs to build full systems. And to do that, you need a lot of IP cores. And if you're doing your chip right, you will have many IP cores. Most of them will be commodity IP cores that you reuse between projects, and then you will add your differentiator, which will be a smaller part of your design. This is how software does it also, where you have, for example, a Linux system and you had just a single application that sets you apart from other Linux systems. Where do these IP cores come from? Four sources basically. You either develop them themselves, you buy them from someone. They can be provided by a platform, or you can find them as open source third-party cores. And either pay the cost for buying them, or you pay the time for developing them. Or in the platform case, you might be locked into a certain platform. In any case, you want all these kind of IP cores to be mixed, and you want to handle them in a uniform way. This is a solved problem in software. We call this package management, where you have a common interface to your packages, or which is equivalent to cores basically for hardware. So FuseSoC is a package manager, and it's also a build abstraction tool, because you want eventually to do something with all these IP cores. You want to simulate them, or you want to synthesize them, or something else. But first we'll need to look at what an IP core is, because some people talk about cores, they talk about CPU cores. In this case, we talk about cores as in something that contains perhaps a test bench, or documentation. You have RTL, of course, and you have other stuff like drivers, or it could be constraint files or anything like that. This is your IP core. Now, next question then is, how do we make this a FuseSoC-compatible IP core? We might need some help for that. Luckily, we have a friend who can help us with that. This is Corey McCoreface. She's a packager herself, so she knows all about how to make packages. So Corey, first thing Corey will tell us is to create a core description file. So this is basically all you need to do to make an IP core, a FuseSoC-compatible IP core. You need to add this core description file, which serves as a manifest of your design. It tells FuseSoC what files you have, what types of files they are, what configure parameters you have, and specific options for different tools that you might need to run through. And I said these core description files, they normally go with the core, but in many cases you might not have access to the actual code. So you can also have these core description files separate from the cores, which is very handy in some cases. We call them remote cores. So the core description files describe the core, but they also describe the relationship between cores. And this is called dependency management. And when you build up your design, it's a hierarchical thing. You have your top level, which instantiates some kind of functional blocks, which in turn might instantiate other kind of blocks, and you might have some common utility designs. And dependency management can be complex, but this is also a solved problem on the software side, where you have SAT solvers for calculating the correct set of dependencies. So if you say that one core needs at least version 1.3 of this core, and another one says you need at most version 1.4 of this core, then FuseSoC's dependency manager will resolve this for you. Once you're getting a larger collection of IP cores, you want to turn them into different libraries. And also, since you can have your IP cores coming from different places, those are probably in different libraries to begin with. So you collect them and manage sets of libraries, we can say. And this has all been talking about how the source code is collected, but eventually we want to use these IP cores for something. And we use targets in the core description files to describe use cases. A use case can be a simulation, or it can be a synthesis target, or for example, running this on an FPGA, or running through a formal tool, for example. So targets describe use cases. And with that, we have basically all we need to start FuseSoc. So what we will do is that we'll tell FuseSoc to run, and then we tell it which core you want to use, which tool you want to use, in case there are multiple tools you can use for the same target, and of course the target. So this is a simulation target. We're using Verilator to simulate it, and we use the core. We can do the same thing, for example, for targeting an FPGA board. In this case, an AMD FPGA board, or an Intel FPGA board, or maybe run it through a different simulator. In many cases, you might have different tools that can perform the same action. But the key takeaway here is that you use a single core description file, use a single interface, and you can run through all of these different tools, which is very good for portability. Now, I think that many of you in this room think we already have this program. We already have something like this in-house. And yes, I believe that's the case. Most companies with a sizable collection of IP cores do have something like this in-house. And this is kind of the point why I'm talking about this. And I think the engineers now can rest for a bit, and all the managers can wake up. Because once you have developed this tool, you are not done. There's a cost caused by maintenance. And if you have this in-house solution and you need maintenance, you have to do it yourself. And that takes away resources that could be spent on building chips instead. And I know that in many cases, these tools are written by someone perhaps long ago who are now in a senior position or have left the company, or either way have much better things to do than keep fixing bugs in this old program. Same goes with feature growth. You need to do it yourself. That's kind of the only option. And training as well, because there's a cost associated with onboarding people to use your tool. They need to be trained on this tool, and they have zero use for that knowledge once they leave the company. If we instead look at what we can do with FuseSoc, maintenance, you can get it for free if you trust that the community around it does the job, or you can buy support contracts. I'm supplying support contracts as we speak for clients. Same with feature growth. If you have something very specific to your use case, you can build it yourself. FuseSoc is open source, so you can just add whatever you want and do your internal things. Or you can buy it from someone who does help with these kind of things. And training. You can still train people in-house. You can buy training courses, or you can, best of all, get people who already know these things. You can use it, you can hire for these skills, which is zero cost. So strength comes in numbers when it comes to these things. There are already a whole lot of FuseSoc users out there. I'm just writing out some of the larger FuseSoc libraries that are available. And these are, some of them are base libraries, some of these come from prominent open source projects. There are also many, many smaller libraries. I know that much of the Pulp platform cores have been FuseSoc compatible. CVA6 that we have heard about many times. Of course, Serve, award-winning RISC-V CPU, and Microwatt, which is a PowerPC CPU. And in fact, most prominent open source projects already use it or have at least looked at using FuseSoc. Strength comes in numbers. Then we have the proprietary users. So just because this is now open source thing doesn't mean that you need to open source your IP cores. Many companies use this in-house. I do not know the exact number, of course. I just can see from support messages and anecdotal evidence that this is used for some reason much in the defense industry and in the aerospace. I have many users. So this thing is a bit slow, sorry about that. Yeah, so if we look at the future, we are looking at increased adoption, of course, the more the merrier. We're looking at extending the base library so that you can get a good design start from the beginning and have lots of IP cores that you can just drop into your design and then add your differentiator on top of that. More EDA tool support. So FuseSoC, or actually it's another project called Edelise, which is kind of the back end to FuseSoC, already supports more than 30 different EDA tool flows. These are synthesis tools, simulators, formal tools, linters, FPGA tool chains, you name it. And we're also looking at more, so we're looking at something like PyPy if you have used Python, or crate.io if you're using Rust, kind of a public package pool where you can easily share your own FuseSoC-compatible cores, and it will be automatically available for all users. And if we look a bit further into the future and get a bit dreamy, I really would like to see this becoming an industry standard. And at some point, I would also like to write world-class documentation for it. Now, I do understand that this is not realistic, so I might change the requirement a bit to something easier. Hopefully that this will at least be achievable. So again, why use FuseSoC? Increase reuse is a big thing. Reuse is kind of my game here. You can reuse your own cores between different projects. You can share cores between different, for example, different research organizations can easily share cores between each other. And of course, you can use different tools. So that one group is using VCS, another one is using Icarus or Celium or something. You can just still share the code without having to rewrite all these setup scripts and things like that. And hopefully it will bring down costs for you, because you will not pay for maintenance of your own tool. You can share this maintenance burden, and you can easily find people who knows these things already. And it has a battle-proven functionality that can be extended. So it's a base functionality that you can extend to fit your exact use case. And FuseSoC lets you focus on your core business instead of the cores. This was supposed to be smoother. Well, I'd like to say thank you for your time, and I do have Core My Core Face stickers for everyone here.